Hello everyone, I wanted to make a video that goes through the candle problem from our lesson so that you can kind of hear me talk through the process of how you use a rate of change to get other various points on a linear function. And to be totally honest, probably the most often is we will use this strategy to intentionally go get the vertical intercept, because you're going to need the vertical intercept if you're writing a linear function. And if it's not given to you, well, you need to find it. And this method that we're going to talk through right now is exactly the method that you would use to find vertical intercepts. So I'm going to share my screen, which is just a screenshot of the candle problem from our lesson. And as you can see in the candle problem, we are told right off the bat that the rate of change for this problem is that our candle length is decreasing 1.3 inches every hour. And so that's trying to make sure that it's crystal clear that we know that the constant rate of change for this function, my pen is being slow, it's got a delay on it. I hope that goes away soon. Okay, so the constant rate of change is a negative 1.3 for this problem. So for every single hour, the length decreases by 1.3 inches. So in 2 hours, it would decrease 2.6 inches, etc. So if you look at the information that we're given, what we know is that at the 2.5 hour mark, the length of our candle is 12.5 inches. That's the information that we're given. And with the rate of change, of course, we're wanting to now figure out how long would the candle be at 3.9 hours, or what about at 1.7 hours? So the first thing you have to look at is, generically speaking, it's called the change in the input. But in this particular case, we're looking at the change in time. So how much time is going to lapse from 2.5 hours to 3.9 hours? Well, that would be 1.4 hours in the future, because 3.9 minus 2.5 is 1.4. So this is 1.4 hours into the future. But remember, with every hour, the candle decreases by 1.3 inches. So how much is the candle going to decrease in those 1.4 hours? Well, if you just multiply that change in time by the rate of change, then you will find out exactly how much the candle should be decreasing in that length of time. So I'm just going to grab my phone here because I don't have it memorized from the slideshow. So 1.4 times negative 1.3 is negative 1.82. Okay, so what does this tell us? Does this mean that the candle is literally negative 1.82 inches at this moment in time? No, of course not. This is just telling us how much the length of the candle is going to change by. Delta L, remember that triangle is just the Greek letter delta, and it means change. So it's not that your candle is literally going to be negative 1.8 inches long. It just means that it's going to change by, the length will change by negative 1.82 inches in that amount of time. So how long will a candle really be? Well, whatever 12.5 minus 1.82 is, which is, wrong button, 10.68. So at the 3.9 hour mark, the candle will be 10.68 inches long. Now, if you think about it, that makes sense because we're moving into the future. So we do expect that the candle is going to be shorter at this moment in time because it's decreasing with every hour that goes by. Okay, well, what about how long was the candle at the 1.7 hour mark? Now, remember, as far as the original information goes, the only thing we know is how long the candle was at the 2.5 hour mark. So you kind of have to, in this case, build from there. So now I'm going to change colors so that it's hopefully differentiable. Okay, so now how much time is changing this time? To get from 2.5 hours back to 1.7 hours, how much time are you moving? And in this case, what direction are you moving? So the difference between 2.5 and 1.7 is 0.8 hours. Not a full hour has gone by, just 0.8 hours. But are you going 0.8 hours into the future or into the past from this reference point? And in this case, the answer is in the past. So your change in time, change in input is negative 0.8, going back in time. Okay, but how much would the candle have changed in that amount of time? Notice it's not even a full hour, so it shouldn't even be a full 1.3 inches. It's going to be a little bit less than that. Well, how much less than that? Well, let's just find out. So you take your change in time, negative 0.8, multiply it by the rate of change per hour, and let's see what this one gives us. Again, I don't have this memorized, not necessary. So I'm going to take negative 0.8, I'm going to times it by negative 1.3. And it turns out that the candle should change by an amount of 1.04 inches. Now, again, does that mean the candle is literally only 1 inch long in this moment? No, that's just telling us how much the length would have changed by in that span of time. Now notice this time my change in L, my delta L, is a positive value. 1.04 is positive. And that makes sense because you're expecting the candle to be longer an hour ago. Oh, not quite an hour ago, but 0.8 of an hour ago. It makes sense that this is a positive number because I'm now going to take that 12.5 reference value and I'm going to add on those 1.04 inches to get my final answer here. So the actual length of the candle at that moment of time would have been 13.54. And again, when you think about it, it makes sense because of course the value at 1.7 hours, the length of the candle value is bigger than it was at 2.5 hours because again, the candle has been decreasing over time. Okay, so then, like I alluded to earlier, a lot of times what you're going to need to find is the vertical intercept in order to write a function. And remember that the vertical intercept is always paired with 0. So at some point in time, we are going to want to know how long this candle was in the beginning. And if we use the 2.5 hour mark as our reference value again, so the fact that at 2.5 hours, the candle was 12.5 inches long. So if we use that as our reference, we're just going to apply the same logic as before. So how much back in time, how much back in time are we needing to go? Well, that would be negative 2.5 hours because we're going back in time, 2.5 hours. So how much would the length have changed? Well, back in time, 2.5 hours at a rate of negative 1.3 inches every hour tells me that the change in the candle for that span of time, negative 2.5 times negative 1.3 is 3.25. So again, does that mean the candle was 3.25 inches in the beginning? No, that just means it was 3.25 inches longer than at this moment. So using the 12.5 as our reference, we now know that the candle would have changed by 3.25 inches. So 12.5 plus the 3.25 tells us what our actual starting value of the candle was, which in this case would be 15.75. So we know that the original length of our candle, or the vertical intercept, would have been 15.75. And now you have all the information that you could need to write a linear function. We know the rate of change, or the CROC, is negative 1.3. We know the vertical intercept is 15.75. And so now you could write L of t equals, negative 1.3t plus 15.75. So the strategy is always the same. You look at your change in your input first, multiply that by the rate to figure out how much the outputs change, and then just add that on to your reference value. Now, just to make sure that the process is, crystal clear, for lack of better words, I'm going to completely take away the context because it gets trickier, to be honest, when there's no context to like wrap your brain around. Like in this case, I can imagine the candle getting shorter as I burn it, or I can imagine that the candle was longer back in time. But if you're just given a very generic, situation where it's like, hey, I want you to work with a constant rate of change that is equal to, I don't know, 2.4. And I want your linear function to contain the point, 5 comma -1. I don't know. I'm making all this up. And with this information, I want you to create a linear function. Okay, well, again, a linear function needs the rate of change times the input variable plus whatever the vertical intercept is. So when you're looking at this information, you're like, okay, did they give me the croc? Well, yes, they did. Did they give me the vertical intercept? No, because this ordered pair is not an input value of 0. It is not paired with 0. It is not the vertical intercept. So that is not your VI. So you're going to have to find it. And how you find it is the exact same process we did with the candle problem. So what I have is the ordered pair 5 comma -1. But what I want is the ordered pair with 0. So you just ask yourself, how am I going to get there? How do you get from 5 to 0? Well, in this case, you'd have to go backwards 5 units. That's the change in input that would be necessary in order to get from where you are, 5, to where you want to be, 0. Now, that's the change in input. But how much are the outputs going to change? Well, I don't know, but I can easily find out using my rate of change. So if my change of input is -5 and my rate of change is 2.4, then by multiplying those, I can figure out what my change in output should be. So -5 times 2.4 is -12. So does that mean the vertical intercept is -12? No, that's just telling us how much the outputs should change. Now remember, where are you changing from? Ah, yes, your reference value in this case was -1. So you're already at -1, and now you know that the outputs have to drop by 12 more. So essentially -1 plus -12 will tell you that your final landing place is actually -13. The actual vertical intercept is -13. So we had the rate of change. We can use the rate of change to go get the vertical intercept. And now we have everything we need to write our linear function 2.4 times the input variable. We'll just use x because it's not a word problem. And in this case, it's a -13 for the VI. Okay. All right, so that's just a little bit of a talk through, obviously for the candle problem, but I wanted to sneak in that last one at the end just to make sure that the process is solidified. So hopefully that helps and you can progress through the lesson smoothly. Remember, there's a checkpoint in there to help you see how you're doing. And then of course, mandatory homeworks or whatever else is in there. Just make sure you're paying attention to what's in the assignments. Okay, thank you guys.